to group the following numbers into different groups. You get to decide how many groups, what type of groups. Okay, you have to have at least 2 groups, because if there's only one group, then it's just a list. It's not a group. Okay? So, choose who's going to be your first writer, and then the other 2 are going to help to decide which things go in what group. Alright, go.
There's like
Turn and start your
the ones with
What is it? What does she mean?
Okay, so I think there should be 2 groups, real numbers and like
Alright, so it looks like most of us at least group them by things that have eyes and things that do not have eyes. Some of us took it a step farther and split apart the things without eyes into like whole numbers, so like 0 to fractions, 4/3, 1/2. And some people took it a step further and then listed the 0.75 as a decimal, which is also fine. And then some people took the eyes and said stuff that is just eyes by itself, like -3i, -2i, and the 4 plus i's and the 2 minus 3i as a separate group as well. So remember that the things that just have eyes are called imaginary numbers. The things that have a real number and an imaginary number are called a complex number, because they have both. However, I do want to draw attention to this one. Where did we put this one?
Equation.
You put it with your eyes? With your other eyes? Did anyone not put it with your eyes? How many eyes do you have?
0.
There's 0 eyes. So if there's no eyes, is it an imaginary number? No, what would it be?
5.
It would just be 5, so it would be a whole number actually.
Yeah.
Alright, so next up, you're going to pass your marker. And this time you're going to group your functions together in whatever type of groups you want. Which one of our degrees gives us quadratic functions?
4.
Not 4. No. Go the other way.
3.
Nope.
2.
There you go. So it is a function with a degree of 2. Okay? And we also started by, on our first page, we looked at complex numbers. So those are things that can be written as a plus or minus bi. Yes, no, maybe. Alright, so pass your marker again. This time, you're gonna work the following 2 problems. We are adding and subtracting. You can erase your previous stuff. So most of us were able to get that first one. So we're adding the real parts and the imaginary parts. But then on the next one, -2 plus 2 gives us what? 0. So we just end up with 8i. Yes? Now, we've been treating I like a variable, but what does I mean?
It's when you have a negative on the square root.
Yeah, so when we have the square root of a -1, that is what gives us an I. Yes? So what does that mean that I squared is equal to? -1, right? Because you would square both sides? Alright, because you're going to need to do that. So when we add or subtract, we just combine the terms. However, when we start to multiply, you might have to use the fact that I squared is equal to -1. So pass your marker.
No.
Alright, so on the first one, looks like most of us just were able to distribute. So we got -8 plus 12. What do we have to do on the second one though?
3 times
Boy.
Yeah, we have to multiply both things by our second. So we have 8 plus 6i minus 4i minus 3i squared. But then what did we say that I squared is? -1. So our -3 becomes +3, and 8 plus 3 gives us 11. And then 6i minus 4i gives us 2i. And then the thing that we have to be careful about on our next one is remember that to square something means that I multiply it by itself. So we get 9 plus 6i plus another 6i plus 4i squared. So +4. So the I squared gives us -1. So we get 5 plus 12i. Yes, no, maybe? Alright, you can make your way back to your desk. We're going to do 2 last examples all together now. Because I feel like most of us, at least, even if we didn't remember how to do addition, subtraction, and multiplication, it's kind of intuitive. Our division, however, is a little bit different. Yes, no, maybe. Do we remember what we do with our division? No? Okay. So, we want to do with our divisions of our i's kind of like we do with our square roots. Remember, we don't like square roots being in the bottom. We also don't like i's being in the bottom. Okay? So what might I do here to get rid of the I in the bottom?
Times it.
5.
2i. Oh wait, no, -2i.
Just -2i?
4 minus 2i.
Okay.
Yeah, basically.
Am I allowed to just multiply it by something because I feel like it?
You have to multiply the top as well.
Ah, because now what are we technically multiplying by?
1.
Alright. I'm good with that. So if we multiply out the bottom, like we did on the previous page, 4 times 4 gives us what?
16.
Okay. 4 times the -2i gives us negative, but yes. And then we also have another -8i and a positive 4i squared. Now, what can we do with our I squared?
-4.
Yeah, it'll be a -4, so I can combine that with my 16. But what's my -8i minus 8i going to be?
-16i.
Okay, so did I get rid of the 16i, or did I get rid of the I in the bottom? If we still have a 16i in the bottom, do I still have i's?
Yeah.
Yeah, okay. Well, we don't want i's in the bottom, yes? So is there something that we could have changed about this here in the middle that would have made the i's go away?
Just make one positive.
Okay. So if one of those was positive, what would I have had to multiply by to get a positive instead?
4 plus 2.
Ah, okay. So notice now if I have 4 times 4, that gives me 16. 4 times a positive 2i, that's where the 8i comes from. And then the -2i times 4 is where -8i comes from. But now when we multiply together -2i times +2i, this becomes -4i squared. Yes, or maybe? Okay. So then, what do we get when we multiply the top?
8.
Okay.
8 plus 4i plus 12i plus 6i
Plus 6i
squared.
squared. Okay. Again, what can we do with our I squared?
Negative 1.
-1. So this becomes 8 minus 6, which gives us
2.
2. And then our 4i plus 12i gives us
16i.
16i. And then my 8's are going to go away, which is what we wanted. And then this becomes a plus 4. So 16 plus 4 gives us 20. So did we get rid of the i's in the bottom? Yeah, which is what we wanted. Okay. Now the only last thing that we want to do is just like with our previous stuff, kind of like how each of these looks. We want it to be like a real number and an imaginary number with just like addition or subtraction in between. So we want to split these up. So we would have 2 over 20 plus 16 over 20. Because now 2 over 20 is our real part, and 16 over 20 is our imaginary part. Are we okay with that? No. So our real part is like when I said like a plus or minus bi. Your real part is just the number that doesn't have anything with it, right? Just a real whole number. Your imaginary part is whatever is with the I. But can I reduce either one of those? Yeah. What is 2/20ths reduced to? 1/10. And then what does 16/20ths reduce to?
8. 4 over 5.
4 fifths. No. That would be your answer. What questions do we have about division? So the division kind of combines all the other things. The multiplication and the addition and subtraction. Questions on any of our steps for that? Right, are you ready for our last kind? So the whole reason that we have imaginary numbers is because we said that they are what give us from when we have quadratics, right? So notice, well, how have we solved quadratics in the past? What have we done with them? We factored them, right? Right?
Yeah.
Okay. So remember we use our AC method. So I have 3 times 5 gives us
15.
15. So what multiplies together to give me 15? That adds together to give me -2.
-5 plus 3.
That would give me -2. But does that give me a positive 15?
Oh. Watch it.
And if it was 5 and 3, that gives me a positive 15, but that doesn't give me a -2. So are there any two things that I could multiply together to give me positive 15 that add together to give me a -2? No. Okay. What do we do then if I can't factor it? Do we remember?
Quadratic formula.
We use the quadratic formula. Do we remember our quadratic formula?
No.
No, okay. Well, then let's remind ourselves of that. So we have x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So the quadratic formula helps us to solve things that we couldn't have factored otherwise. It's also what's going to lead to us, if I have a negative underneath this square root, what does that mean we have? An imaginary number, right? Or a complex number, yes. No, maybe? So, remember that the A, B, and C represent the coefficients. So, 3 is my A, -2 is my B, and 5 is the C. So, you're just plugging those in to your formula. So for times 5 gives us 20. Times 3 gives us
60.
60. What is 4 minus 60?
56.
Almost.
Wait,
Negative 56. So if I have a negative underneath our square root, we said that means that we have what kind of number? It's a complex number. So we're going to pull that negative out to become an I. And now what goes into 56? Like what is the square root of 56 reduced to? So 56 is not a perfect square, right? But like does 4 go into 56?
Yeah.
How many times? Almost 14 times, right? So if I have a 4 is special because we can rewrite 4 as 2 squared, yes? So if we had the square root of 2 squared times 14, what can we do with that 2 squared? It gets to come outside of the square root. Yes, no, maybe? Are we all okay? Or do we have any questions so far with those steps? Again, the quadratic formula is not necessarily hard to plug in, but it is combining a lot of different knowledge kind of all together. So that's what can kind of be confusing because you're bringing together a whole lot of stuff. So then the last step is just to split this up like we did the last one. So 2 divided by 6 plus or minus 2i square roots of 14 divided by 6. And then we just tend to write that